guys, welcome back. So what we're looking at today is lesson 12 and 13. The meaning of exponents is lesson 12. So let's go ahead and jump right in. All right, so what we're looking at here, the genie's offer. You find a brass bottle that looks really old. When you rub some of the dirt off the bottle, a genie appears. The genie offers you a reward. You must choose one, $50,000, or a magical $1 coin. The coin will turn into 2 coins on the first day. The 2 coins will turn into 4 coins on the second day. The 4 coins will double to 8 coins on the third day. The genie explains the doubling will continue for 28 days. So for number 1, the number of coins on the third day will be 2 times 2 times 2. Write an equivalent expression using exponents. So hopefully you guys have seen exponents before. You should have in 5th grade. So exponents, remember, we have a base number, and that's the number that's being multiplied together. So that's going to be our 2. And then our exponent, the little number that goes up top, is going to be how many times we multiply the base number to itself. Well, we're taking 2 times 2 times 2, so we've got 3 2's there, so it's 2 to the third. So it's 2 to the third power. So for number 2, what did 2 to the 5th and 2 to the 6th represent in this situation? Well, if 2 to the 3rd is the 3rd day, then 2 to the 5th would be the 5th day, and 2 to the 6th is the 6th day. So 5th and 6th day. And so now we want to evaluate without a calculator 2 to the 5th and 2 to the 6th. So 2 to the 5th is going to equal, well, 2 times 2. So if you think about this, 2 times 2 times 2 times 2 times 2. That's our 5 2's. So 2 times 2 is 4. 2 times 2 is 4 times 2. 4 times 4 is 16 times 2, which is 32. Now, we're taking 2 to the 6th, which means we just need to multiply our 2 to the 5th one more time by 2. So 32 times 2 is 64. So for number 3, how many days would it take the number of magical coins to exceed 50,000? So right now, in 6 days, we're at $64. But remember, this is going to keep growing faster and faster and faster because we're doubling every single time. So we're going to list out. So we've got 64 is 2 to the 6th, 2 to the 7th, 64 times 2 would be 128. And then we multiply 128 by 2, that'd be 256. So this is 7th day, 8th day. 256 times 2 is going to get us 512, so that's the 9th. 512 times 2 is 1,024, so that's 10. Times another 2 for the 11th day is going to be 2,048. We're getting up there. Multiply by 2 again, we're going to get 4,096. That's the 12th day. Then we get to 8,912. That's the 13th. Now we're at 16,384. That's the 14th day. 15th day is going to be 32,768. That's our 15th day. And our 16th day is 65,536. It's the 16th day. So somewhere in between the 15th and 16th days is when we'd reach 50,000. So we're going to exceed it at 16 days. So if we think about this, which is the better offer that the genie gave us, the 50,000 or that magical $1 coin? Clearly the magical $1 coin, because in 16 days, we're going to end up with more than the $50,000. So Question 4, will the value of the magical coins exceed $1 million within the 28 days? Explain or show your reasoning. So on the 16th day, we know there's 65,536 coins. The next day, there will be over 130,000. Then the next, over 260,000. Then it'll be at 500,000. So then the next, it'll be at 1 million. So it's only going to take 4 more days. So on the 20th day, so 2 to the 20th is going to give us 1,048,576. And that's only the 20th day. Just imagine what the 28th day is going to be. Which I always find this interesting, so I will tell you. On the 28th day, which would be the end of this, how many days the coins will double, we will end up with 268,435,456. So, which offer is the better offer? Definitely the magical coin, for sure. So this is all about exponents. We're taking and looking at these exponents and understanding how it's going to double and how it starts getting bigger and bigger and bigger the higher we go with those exponents. Okay, so exponents is your key word for this lesson, exponents. All right, make 81. Here are some expressions. All but one of them equals 16. Find the one that is not equal to 16. Well, 2 to the third power is 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8, times another 2 would be 16. 4 squared is 4 times 4, so 16. 2 to the fifth is going to be 32. Divided by 2 is 16. And 8 to the second is 8 times 8, which is 64. So this is the one that does not equal 16. So we have to be careful. Most times when you see 8 to the second power, you're going to think right off the bat, this is one of the most common mistakes, is that you're doing 8 times 2, which is 16. But you're not. You're taking 8 times 8. You're taking 8 times itself twice. So be very, very careful with the exponents. All right, so now we want to write 3 expressions containing exponents so that each expression equals 81. Well, what's the easiest? 81 is a perfect square. We take 9 times 9 to get it. So 9 to the second power. Now, we could throw some division in there. If we go to 9 to the third over 9, that's also going to equal 81. We can use 3 as well. So 3 squared gives us 9, times another 3 squared will give us 9, which will give us 81. Which also means we could do 3 to the fourth. So lots of different ways that we can take and do these. These are just a few examples. There's many, many more that we could take and come up with. As long as it's equivalent to 81, it works. All right, so now we're going to take a look at lesson 13. Lesson 13, which is expressions with exponents. So is the equation true? 2 to the fourth equals 2 times 4. Is that true? No, 2 to the fourth is 2 times 2 times 2 times 2. There should be another 2 in there, or 2 fours. So this is false. 2 times 2 times 2 times 2. All right, here we have 3 plus 3 plus 3 plus 3 plus 3. So we've got 5 threes. Does that equal 3 to the fifth? No, it doesn't. Remember, exponents mean we're multiplying. So this is false. What about this one? 5 to the third equals 5 times 5 times 5? Yes, that is true. The next one, 2 to the third equals 3 to the second. Is this true? Well, 2 to the third is 2 times 2, which is 4, times 2, which is 8. So we've got 8 equals 3 times 3 is 9. That's false. So just because you switch the exponent and the base, you're not going to get the same answer. So remember that. All right, 16 to the first equals 8 to the second. Remember, what is 8 to the second? It's 64, not 16. So this is also false. All right, we have 1/2 times 1/2 times 1/2 times 1/2 equals 4 times 1/2. Is that true? No, that's very, very false. If the 1/2 were taken to the 4th power, yes, but no, not the case. All right, and the last one, or there's one more, it's on the other page. Number 7, we have 1/2 to the 4th power equals 1/8. Is this true? No, because if we take 1/2, I'm going to use this one here since it's all wrote out. 1/2 times 1/2, that gives us 1/4, times another half is going to give us 1/8, times another half is going to give us 1/16. 1/8 and 1/16 are not the same. So be very careful. All right, and the last one, we have 8 squared equals 4 to the 3rd. So 8 times 8 is 64. 4 to the 3rd. 4 times 4 is 16. Times 4 is 64. 64 does equal 64. Oops, I'm so used to writing false. That this is true. All right. What's your reason? In each list, find expressions that are equivalent to each other and explain why they are equivalent. So if we look, we've got 5 times 5. 5 times 5 is the same thing as 5 squared. Remember, base is the big number. How many times we multiply it is the exponent. The next one, 4 to the 3rd power. So which one goes with 4 to the 3rd power? 4 times 4 times 4. Here we're adding 6's. Here would be multiplying, so that doesn't work. That one's completely different. So A and D are the same. When we add multiple numbers together, it's the same as multiplying by how many times we add them. So be careful with the difference there. Oops, too far. All right, we have 11 to the 5th power. And then we have 11 times 11 times 11 times 11. So A and B are going to be the same here because it's multiplying. Exponents always about multiplying. All right, 1/5 so 1/5 times 1/5 times 1/5. So that would work with this one. It's also going to work with 1/25 because 5 times 5 is 25 times another 5 is 125. So it'd be 1 over 125. And the last one, so when we have a fraction take it to an exponent, the exponent is going to go to both the top and the bottom. So that means 5 squared is 25, 3 squared is 9. So these two will work, okay? So be very careful when you're doing exponents. Like I said, it's always about multiplying. And so it's taking that base number times itself, however many times the exponent says. All right, if you guys have any questions, feel free to ask. Have a wonderful day. Bye, guys.